is the second week of the Philosophy and the Talents of the Future course. I hope so far you have got an idea of what this course is about, what is AI, what are some main questions in the field, and why it's worth diving deeper into the topic of AI and AI safety and the future of humanity. In this week, we are going to be concerned with a few more distinctions, and we will try to better understand what AI does and try to situate it a little bit further into our societal context and the applications of AI and how it's already been useful in many different domains. So, to do that, we have three chapters of a very interesting book that you already have access to. The book has a lot of examples and a lot of drawings, as you may have seen already, and it's pretty pleasant to read, and it gives you a good sense of what AI is and does pretty quickly. So I highly recommend reading all three chapters. And in addition to that, you can watch the video on neural networks, which has also been a very helpful video for many people to understand this main neural network architecture that is currently prevalent and is used in all the models that we're going to be talking about in text generators and in image generators, and basically everything that currently works and is popular and people widely use is based on the neural networks architecture. So it's going to be very useful for you to have a good understanding of what is a neural network. Even if you don't really get all the math behind it, it's good to have a picture of what this is. Back to the book here in chapter 1, you'll see the what is AI question. AI is everywhere. What do we mean exactly by AI? And called AI in this book is very similar to what we are gonna call AI in this course. Like I've said before, we mostly mean machine learning, deep learning, algorithms, and deep neural networks in particular, because that's what's very successful at the moment. So that's something that catches our attention. And what we do not mean as AI in this book and in this course is whatever science fiction AI you may have seen or read about, and all these other funny things. So the book is very helpful in giving you some distinctions about what AI is. So here's a distinction between machine learning algorithms and something that you can program, right? So what's the difference between machine learning, ML, and rule-based programs? In machine learning, you have a training process. In rule-based programs, there's a developer who's coding exactly the rules of the program. So there's no training there. The program doesn't learn anything. It outputs what it has been coded to program. And what we have right now is machine learning, which means that you give some information to the system, some training distribution and a learning algorithm, and then the model finds something as part of its learning that's going to be executing, hopefully, what the developer wanted it to execute. But it's not certain what the model is going to find. And what the model finds is called a policy. And the uncertainty surrounding machine learning and what the model is going to find is a lot of the reason why current AI systems are considered to be potentially very dangerous, because we cannot code rules and instructions into the systems. We expect the models to find something through training. So you're gonna read about rule-based programming here. You're gonna see how this works with a few examples, and you're gonna see what training AI means, what I just described. This distinction is pretty important to keep in mind. The rule-based AI is the old-fashioned AI you may remember from last week. So it's important to know what we have now. And as you see, this book is pretty pleasant to read with many drawings. And even though it's many pages, it's pretty helpful and pretty fast to read, especially within context of trying to understand what AI is right now. So here it's good to make a first stop on 4 signs of AI doom. What does this mean? How could AI could potentially cause harm or cause some problems? And you see here one first warning sign is the problem we may want the AI to learn might be too hard, too difficult to specify. So we cannot be sure that the AI will understand what the problem is exactly, so that it can help us with the problem. So imagine hiring someone who you cannot really explain what their job should be, right? So that makes things pretty confusing. You want someone to do a task for you, but it's not easy for you to exactly articulate what you want them to do. On a similar note, the problem is not what we thought it was. We don't. There are cases where we might be telling the AI to do a certain task, but we're not really telling the AI to do what we think we are. This is often called outer alignment, and it has to do with how we describe the task again to the AI. And as you'll see, you may try to find some examples. It's not always straightforward that you can communicate what you need the task to be. Warning sign number 3, there are sneaky shortcuts. You might not know if the pathway that the AI chooses is the best one, right? So the AI might find some kind of solution that is an unfortunate shortcut and is not what you would ultimately want it to do to solve your problem. Warning sign number 4, there was something wrong in the training data of the AI. So the model learned from flawed data, and that could cause problems as well. And that's a pretty good summarization of things that could go wrong. And again, we're talking about machine learning. Now, in chapter 2, again, pretty useful to have some examples of where is AI exactly, where do we use it. You're probably using AI a lot more than you realize already, because it is in many of the devices that we use. It already takes some jobs that have to do with writing, and that have to do with using algorithms to filter text. This so far has been pretty successful. So it's good to go through this section of the book. Maybe there are some jobs, for instance, that are so tedious for humans, and it would save us a lot of trouble and monetary costs to just automate it, to just get a robot to do this job. So that's one example of maybe automation would be good, but in which cases, right, we have to be careful. Under what conditions would you trust an AI model to do a certain job? And some examples with like deep fakes, different applications of AI. And one general observation about the models we have so far is that the narrower the task, the smarter the AI. What does this mean? AIs can be very good at chess, for example, but they don't seem to be able to do things that your average human can do very successfully because they require general intelligence. So the difference between narrow and generally smart is this, right? Narrow intelligence has to do with one specific task, and so far we have AIs that can be pretty good, even beyond human intelligence at narrow tasks, but don't have this general capabilities. And you will hear the term AGI, artificial general intelligence, for these generally capable models that don't just do narrow tasks, they do everything that your average human being could do. So these are models we currently do not have. However, AI labs are interested in pursuing research in how we can have models like that. And a lot of the concerns we have, and we will be interested in this course, has to do with what are the potential dangers of having models that are about as capable as your average human being, and how could this get out of control. So you can keep reading the examples here, are pretty helpful. And finally, in chapter 3, okay, how does the model actually learn? What does learning mean? And here's the more interesting technical part that's definitely worth knowing the terms so that you don't get confused, right? Deep learning. Why is it deep learning? Because we have neural networks, artificial neural networks. Like I said in the previous week, we had neural networks for a while now. It just they didn't work until a few years ago. And they're deep neural networks because we have many layers, as you're gonna see in the neural networks video on YouTube. The idea behind connexionism that inspired artificial neural networks is that you can do something that the brain does, but artificially. What does the brain do? It has all these many synaptic connections in the brain in the form of a network, and this is called connexionism, and this is independent of the hardware or the physical substrate. That's what functionalism says. So regardless of what kind of substrate you have, hardware, right? This doesn't really matter. All that matters is that you have these connections, and whether it's a biological substrate or an artificial one, it doesn't matter. It's gonna work. It's gonna be a deep neural network, and you get intelligent behavior out of that. So that was the bet of connexionism, and so far it seems that connexionism is true because neural networks work, and we have language models that speak English and many other languages. So here you see some of the comparison to the human brain. That's very interesting to consider, especially if you're into neuroscience and psychology, you might be able to see the similarities or the analogies and try to brainstorm on how the similarities exactly map out. Maybe they don't as much, or maybe they do. That's something worth thinking about further. And yeah, so what's left now is go watch the video, and you'll also find a very helpful machine learning glossary by Google, which is not meant to be read necessarily, but it's useful to save it so that you can use it for references. If you don't understand the term, it's good to go and look it up. So these are the readings. Please go watch the neural networks video and keep the glossary for references. See you next time.